This lesson is on slope and rate of change. This is our new unit, and it is 3-1. Slope is the rate of change in a relationship. Slope or rate of change is a ratio of the following: change in the dependent variable divided by change in the independent variable. The dependent variable will be our y, and the independent variable will be our x. On a graph of a linear, that means our graph is a line, relationship, slope describes the steepness of a line. So, like when you're driving along a road and then you go up a big hill, that could be a steep hill, and then you go down a hill, that could be very steep. So think of it kind of like you're driving a car. There's no slope, and then it slopes up, and then it slopes down. All right, so from that, let's look at the different types of slope. So here's our line that we're looking at, and we always read from left to right. So we always have to start over on this side. Well, our line is right here on the side, and it is going up. So therefore, that would be a positive slope. It increases from left to right. All right, so when the opposite is happening, again, starting over here on the left, so there's the line. This line is going down. So that would be a negative slope because it is decreasing from left to right. Anytime our line is horizontal like this, that is a zero slope. That means the slope is just zero. It's not going to be a positive number. It's not going to be a negative number. It's just zero. And then when we have a vertical line like this, that is said to be an undefined slope. Okay, so these are the 4 types of slope. There's a difference, and you have to pay attention of when you are being asked to find the type of slope, and if you are being asked, and we're going to learn about this on the back of the page, the value of the slope. So let's look down here and try a couple of these. Okay, so starting with line A, that would be this line right here, and we only have 4 options for answers right now, and they are asking about the type of slope. So line A is a horizontal, so what type of slope would that have? Look up above in your notes if you need to. That has a 0 slope. All right, line B, this is line B. And remember, we read from left, so we always have to find our line over on this side. It's right here, and it is going down. So line B has a negative slope. Line C is this vertical line, which is that special word that has an undefined slope. And lastly, D, starting from the left and moving up, that has a positive slope. List any strategies to help you remember the difference between a graph with an undefined slope and a 0 slope. Well, a lot of times when I'm teaching it and I'm talking about a car, I usually say, well, we can drive a car along the road, and that's a 0 slope because we're not going up a hill or down a hill. Once we go up, that's positive, and down is negative. But we can't drive a car straight up in the air like this. And so that's that special word of undefined. However, another option is that you can think of the line that is vertical as the line that goes up and down, and therefore that is undefined. So that might help. Up with a U, undefined with a U, up and down, okay? And the other option would be for the horizontal, the Z is special there, horizontal line has a 0 slope. They both have Z's in it. So hopefully that will be something that's helpful. All right, now we have looked at the type of slope. Now we're going to learn how to find the actual slope, the value for slope from a graph. To find the value of slope from a graph, find the ratio of the dependent change compared to the independent change. All right. I probably should have said the vertical. That makes a little more sense. Sorry, I thought something wasn't looking right. Which the vertical is the dependent. It's the y value change compared to the, this should be horizontal. So you might want to stop and take out what I wrote in red. It's not necessarily wrong, but I think it'll be more helpful for you to have the vertical change compared to the horizontal change. Or a lot of times we refer to this as the rise divided by the run. The rise, think about rise, up and down, okay? Or run, left or right. So the vertical change, vertical, this is vertical, divided by the horizontal change. To do this, choose any 2 points on the graphed line, then draw a right triangle to count the rise and the run. Always simplify your ratio when possible, and remember to check if the graph has a positive or negative slope. All right, so let's try this. So looking at this first one, follow the steps to find the slope of the graph. So the first thing it's asking us is for the rise. So if we look over here at the rise, which is right here, see they took these 2 points that were on the graph and they created a triangle by rising and running to get from one dot to the next. You got to go vertical and then horizontal. And so the rise would be 1, 2, 3, 4 units. There's 4 units for the rise. And the run is 1, 2, 3 units. So the run is 3. And so therefore, the slope of the graph is 4 over 3. It's a fraction, 4/3. Now you want to make sure you go back and determine if the line is positive or negative. So see how the line is going up? So that's a positive slope. So we're going to leave this as positive 4/3. Okay, let's try some more here. So looking at this number 2, so we can see that we already have 2 dots that are placed here on our graph, and that's fine. Okay, so we're going to start at 1, and it doesn't matter which one, and we're going to rise and run. So you can either go that direction or you can go this direction. That doesn't really matter, but you only need one of them. All right, the other thing we need to pay attention to is when we figure out the rise here, we need to go look over here and make sure, see how this is counting by ones? So the rise here is just 1. It's just going to be 1. See, that's 1. And then we need, if we're counting the run, see, we're counting from here to here, and we got to double check what we're counting by here. These are ones. So we run 1, 2, 3, 4. So that's 4. And so the slope would just be 1/4. And then double check, is this a positive or is this a negative slope? Starting at the left and moving up, that's positive, so it's positive 1/4. All All right, let's look at the next one. The next one, we don't have any points that are shown on here, but what you need to remember is a line is a bunch of points that are all connected together. They're all closed points all the way along here. That's what forms this line, okay? So what we're going to do is we're going to find places on this line where this line goes through one of the little crisscrosses in the grid. So this is the grid right here. And if you look, the grid has a bunch of squares. So see how these squares have 4 corners? We want to find where the line goes through one of the 4 corners. So if we follow to right here, see that's not going through one of the corners of the square. So if we keep going, you can see right here, the line is hitting that corner of the square. So we're going to put a dot right there. And then we're going to keep going until we find another place. And right there's another one. See where the line is at the corner of the square? And see how many of them you can place on here. That's what I see right there. Now, we need to use 2 of them. I just used 2 that are close together. And we're going to rise and run to make a triangle. Now you could have used these 2 if you wanted to. You could have used these 2 if you wanted to. It really doesn't matter because the rise here is 1. And again, you got to look over here at your numbers and what you're counting by. And then the run is 2. And again, we're going from 4 to 6, so that's 2. All right, so rise over run. That fraction would be 1 over 2. Look at the line from left to right. What is the line doing? Is this a positive slope or a negative slope? It's a negative slope. So we're going to put a negative in front of our fraction. So that is a negative 1/2. And if you watch what happens. From this point, we go down 1, right 2. Down because it's negative. Down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. See, so that shows you the slope of the line. It shows you how the line is moving. Okay, let's look at this next one. If you want to pause this and see if you can figure out some places where your dots, some points would be on this graph, feel free to do that, or you can work right along with me. Okay, you can see that there's one right here where the line is, and it's at one of the corners of the graph. If we follow this up, okay, this is not on a corner. Remember, we're looking at the 4 corners of the squares, okay? Oh, there's one right there. So we're going to put one here and keep going, and I see another one there and another one there. And then we need to draw a triangle. So I'm going to draw mine this way, okay? So if I want to look at the rise first, okay, the rise, remember I've got to come over here and look at what I'm counting by. So this is counting by 3. See, 3, 6, 9. So it's not really 1, 2, 3 blocks. If we look over here, it's 3, 6, 9. So even though it looks like 3 because it's counting by 3s, this is 9. And then on the bottom, these are counting just by 1s. So that would be 2 for the run. So the rise is 9 over the run, which is 2. Remember, it's rise over run. And then you look and see, is this line positive or is it negative? It's positive, so it's positive 9 over 2. All right, very good. All right, let's look at this one right here. Let's put some points on here. You can see one right there, which is at the origin. Remember, that's called the origin of the coordinate plane, where the x and y axis meet. And look and see, I see another place right there where my line goes through a corner of a square. And really we only need 2, but do you see another one? Right here's another one. Okay, and then I'm going to make my triangle, and it doesn't really matter if you go make it on the bottom or make it, you know, if you went this way, that wouldn't matter. It doesn't really matter. Okay, so now we're going to count our rise. All right, so our rise is our vertical. So it looks like 4, but let's go over here and check our y-axis. Are we counting by 1s? Yes, so that's going to be 4. And then our run looks like 3, and we are counting by 1, so that's 3. So our slope is rise, which is 4, over run, which is 3. Double check if it's supposed to be positive or negative. Remember, we start on the left here. So here's my line on the left, okay? We don't read from right to left. We read from left to right. So we have to start over here and find our line, and it's going up. So it's going to be positive 4/3. Okay, look at the next one. Now this line, it has a bunch of these, doesn't it? However, remember that all vertical lines have a slope that is undefined. So even when you're finding the value of the slope, if it's a vertical line like this one, it's undefined. If it's a horizontal line, it's 0. You're only going to have your fractions if it's a positive or negative slope. You're going to actually have to calculate what it would be. Okay, last one. Find all your little points. Here's one at the origin. I see another one here. There's a bunch of them all along here. But we really only need 2. So if we look right here, and we can say, okay, what is our rise? Well, from here to here. Now look, it's counting by 2s, so that's a difference of 2. And then my run, if I just look along the x-axis, these are counting by 1s, so my run is really just 1. So rise, which is 2, over run, which is 1. And then you have to decide, is it positive 2 over 1 or is it negative 2 over 1? So we start up here, and it's going down, so it's going to be negative 2 over 1. Okay, that is our lesson on slope.